So this is a talk I repurposed from Allison's previous workshop on existential hope, where I didn't get to give it because I was on a panel. So instead, it's coming now, but it does have a space component. In fact, it combines, in my mind, a majority of the Foresight Institute's separate tech tracks. It combines biology, biotech longevity, which is one track. It combines molecular nanotechnology. It combines space, and it combines existential hope, and maybe AI as well. So the space portion is abbreviated, but it has a very personal interest to me. But what this is all about is biology. So this is the only kind of example of self-replicating, self-repairing, globally scalable, existent molecular nanotechnology that is not only inside of all of us and every living organism, but has terraformed the Earth. And so this is kind of in the style of Good Cell, an illustration of some of the processes inside a cell. This is a tiny fraction of a single cell with the nucleus on the left, mitochondria at the upper center, and cell membranes and gap junctions on the right. And this is this is the most exquisite machinery that exists and puts this is as complicated as a city, every single cell. And I'm not going to show the animations here, but these are not static. These are dynamically assembling and disassembling machinery. This is a microtubule being assembled or disassembled. And this stuff is going on by the millions in every cell. And unfortunately, this is not the right keyframe from the video that won't play, but this is a video of a single-celled organism hunting. It has no brain, but it's like navigating and hunting and grabbing things, and it's a real-time, soft robot that's processing tons of information that you can't, so small you can't even see it. And it's, there's, a billion of them in every cc of water in your average pond. Now I'm going to pivot to something about the Earth, because this is about combining these kinds of technologies, biotech, nanotech, space tech, to a particular application, and the application is regenerative agriculture, and in particularly regenerative grazing. So if you look at the Earth's surface, most of it's water. About 4% of it is under cultivation, meaning basically row crops or orchards or something like that. And then about 25% of it is shared between rangeland and forest. Rangeland, grassland, it's marginal land in general. It's too hilly, too stony, too dry, in the wrong place to grow crops. And forest land, we don't need to go into that. Everybody knows what it is. But my question is, how can we utilize this land most effectively by combining these technologies? Because rangeland actually supports arguably the most diverse ecosystems anywhere on Earth. When a healthy rangeland has deep perennial grasses with very, very deep roots, it has animals, tightly bunched herds of animals moving around traditionally, being herded by predators and bunching up to protect themselves against predators. And the point is, in every cubic millimeter of this photograph that's not the air, there is all this nanotechnology, biotechnology, evolved super technology that's going on. But the problem is, and that, for instance, also, this is grassland. This is what it can look like when nature manages it, or when humans correctly manage it, and we mostly incorrectly manage it. But this is what Africa looks like in some places where we let it be and where we don't alter it too much. And this is what North America looked like in most places when it was a functioning, integrated ecosystem with all the kingdoms of life, by which I mean animals, plants, bacteria, protists, and fungi. You can make different taxonomies of kingdoms. It's arguable, but that's one way to do it. And in the more distant past, we don't have any photos of what the real herds looked like. These are the herds of animals, 100 million strong, perhaps in some cases, but certainly tens of millions strong, that migrated across essentially all of Central America and North America and built the fertile plains of the Midwest with their meters worth of topsoil that we're slowly mining down to be centimeters worth of topsoil, because we don't have the herds of animals anymore bunched up moving across them. But we do it, and now people have discovered that the way to do grazing that is symbiotic with the health of grasslands is you keep the animals bunched up and they eat the grass, and then after they've been there for a day or two, you move them to the next place and you move them to the next place. And if you cycle them around so that they come back every 90 days or so, things after they move off, they've pooped, they've peed, they've drooled, they've stomped, this actually brings the soil and the grass back to life. This is what it evolved to do in symbiosis. And so you bring it back 90 days later, it's all sprung back and it's super nice. You do this for a few years and you turn your grasslands into these polycultural, diverse, multi-perennial species ecosystems, and there's so much bio above the ground and even more bio under the ground that you can't even see the big animals hardly unless you look. So to move the animals around, now we can start to use space technology because you want to keep them bunched and moving, okay? And that's, in some places you have the labor to do this. In some places, maybe the labor's too expensive or too hard to come by. And so nowadays you can have these little GPS kind of buzzy collars that sit on animals, like some pets have these. So when they go too far from home, it's like a virtual fence. Well, you can do the same thing with livestock. And you can not only move them around from a laptop, on the other side of the planet, you can track each one. You can make virtual fences. You can move the virtual fences. If you find like a straggler, you can make a special fence for that one and move it back into the herd. But how do you decide where they should move? Well, this is where Planet Labs comes in, and companies like it. We do remote sensing of the Earth from space, and one of the things we can sense is you can just combine certain spectral bands, and if you know the kind of thing that's growing there, you can make, we send emails like this out. One of our partner companies, 90+% of New Zealand dairy farmers, I think like 96 or something now, get these emails every day, and it shows them every one of their paddocks. These small units are paddocks. This whole thing is a pasture, and the color here is a derived quantity, some kind of index like differential vegetation index or chlorophyll red edge index. I don't know which one this particularly is, but you can know that, like, okay, let's say we've color coded it where green is optimal. It's like, move the herd, all 100 of them bunched up to this paddock today, but not to that one, that's not ready yet, or that's, and then maybe the next day you get a different map and you move them to number 41. Okay, so I'm gonna just leave it at this, and I'm gonna say that my vision is to combine, and not just my vision, but I think a vision that is achievable and delightful and beneficial for the biosphere, the humans, the animals, our long-term future, our food stability, our health, everything. Well-being of conscious creatures is integrating all 5 kingdoms of life, correctly managed, using information about the local ecology, information from space, information from the ground, information of what kind of world we want to have. And I really believe that this is a thing that is hopeful and doable. There's a space component and all these other components, but it is not some kind of breakthrough thing that's going to require, warp drives and trillions of dollars. This is a thing we can really start to do and are starting to do. Oh, and I want to say one more thing. And for people, I don't mean to get too political here, but for people who say, like, shame on you for wanting animals and we want a plant-based lifestyle, and it's like, this is what you're talking about. Industrial monocrops made with fertilizer that exhaust and kill the soil, and it's so horrible compared to what we could be doing with perennial grasses and fungi. And anyway, enough. Aquaculture is the next frontier after that. Same vision.
Thank you, Creon. We have a question.
Lovely presentation. I was wondering if you have talked to a policymaker, or if you had talked to any of the United Nations representative or delegates to inform them about your idea. I think I do share the rationale, and I do agree with that. I would think the institution would be interested to know that there is more will from the population to go towards a more sustainable direction.
I prefer to say regenerative rather than sustainable, but I hear what you're saying. I don't talk much to policy makers. I'm a science and technology person, and I try and make prototype systems that actually can help with this. particularly from the satellite image and data and satellite remote sensing data perspective. But there are people I work with at Planet Labs and other people I know about who I've worked with before, but work at other places who are more policy oriented. I mean, the policy is a big can of worms, like it is with all of this stuff. And I'd love to talk with people about it. In particular, I'd want to know, like I'd like to talk to the USDA and be like, why aren't we incentivizing this? Why are we subsidizing people to grow corn and soy and exhaust the soil and shove pesticides and fertilizers into it when we could be doing this other thing, which is better for everybody, except for the fertilizer companies and the pesticide companies. So that's another policy problem that has to be dealt with, is you have entrenched players who've captured the regulatory agencies who don't want to necessarily lose profits, but that could be said about practically any problem we have these days.
So my question is traditional farming was that.
About what?
Traditional farming was what you are describing.
There is definitely, this is sort of what I'm advocating. Look back to, what I'm advocating is something slightly different. There's traditional knowledge that we need to pay attention to, particularly before we lose it all. There's the knowledge of nature, which we learn by science and molecular biology, and we learn by science more than tradition. But there's the traditional knowledge, there's the knowledge, scientific knowledge of nature, and then there's techno knowledge, like do it from space, do it with AI, do it with these little Internet of Things devices. I believe that by synthesizing all of those things, including traditional ways, we can get the best of all possible situations. So.
Wonderful. What's your challenge, Creon? How do we
become space cowboys?
My challenge, you know what my challenge is, Allison. My challenge is, what vision do we have for the future that we want? In this case, it's what vision do we have for the future of the grasslands and rangelands and our activities to, what do we want them to be? What do we want the grasslands and rangelands of the world to be? And then by extension, what do we want agriculture of the world to look like? But I think my big question is, what do we want our world, however defined, to be? How do we envision it? Because the problem is everyone is busy envisioning negative outcomes. We all hear about all these risky, terrible things, or they're envisioning, like, which is fine, they're envisioning sci-fi cities in the sky. And I'm like, we might want to do something a little closer to home, since we can. And so it'll help us survive and prosper on our way to the, what is it, gay-based communism, luxury gay-based communism, or whatever my San Francisco friends want to make.
Thank you, Creon.
Thank you.